A little debug problem that I'm going to tell you about. See if you can solve it. So there are two prerequisites before you can solve this problem. The first is you have to know C programming. The second is you do have to have some knowledge of x86 assembly, just a little bit. So, and it's not completely necessary actually whenever I go through and show you what the true problem is and solve it for you. But the question is, you've just written a program in ANSI C, and the program crashes at the instruction in AL, 10 hex. That's where it crashes at. What did you do wrong in your program? So that's all the information. That's all you need to solve it. So you may pause the video now and you can actually answer in the comments below what you think the problem is. So let's go through this step by step. So first of all, in AL, 10, the reason that you crash there is because so in instruction means reading a hardware port. So you're trying to read a hardware port in user mode. You're trying to read 10 hex hardware port in user mode. And hardware ports are typically what drivers use to access, mostly legacy drivers, because most drivers nowadays use MMIO instead of these old ports. But that's where you crashed, and you would crash with privileged instruction. Now a lot of people actually get this when I ask them this question. They get that, this crashes because you can't access hardware ports in user mode. Well, most operating systems don't let you do that. Now Windows 95 actually did. And so there is an IOPL on the eFlag that tells you whether or not you can access ports in the ring. Now, like I said, typically most operating systems disable it. There's really no need to access ports in user mode. Like I said, Windows 95, Windows 9X actually did allow you to do that. Now, one of the reasons you may want to do that is for hardware traces. If you're taking like a bus trace and you're doing a bus trace and you're trying to figure out a problem with the user mode app and you want to stop this bus trace. In order to stop this bus trace, you want the software to trigger on a read or a write to a certain hardware port. You can then instrument your code in user mode with that port access, and then once that is seen on the bus, it can stop the trace. But who's realistically doing that all the time and knows they're doing that? So very rarely. So a lot of people get stuck on this NAL, 10, and they're like, well, maybe you're trying to do printf and it's accessing the hardware, or you're trying to do in and trying to read a keyboard. Of course, these aren't even keyboard ports. This has nothing to do with the video. So they get stuck on that. And that's kind of like me saying that's kind of like if you hit a deer, right? You're going down the road, you hit a deer. And I ask you, why'd you hit the deer? And your answer is because cars can't go through deers. Well, no crap. I mean, that's why you crashed, but that's not the reason you actually crashed. I mean, why you hit the deer. I mean, you hit the deer because, you weren't paying attention. The deer jumped out at the last minute. You couldn't hit the brakes in time. You're going too fast to slow down. I mean, all those are reasons why you actually hit the deer and jumped in front of you. But car can't go through deer is like you saying that, well, you crashed because this instruction can't execute in user mode. Well, yeah, that's why it stopped the program, but why did you even try to do that to begin with? That's what we're trying to find out. So, remember I had said that this was an ANSI C program. Now you know that ANSI C is portable, which means that you don't have any inline assembly. You shouldn't be doing this. The standard libraries, like I said, people are looking at printf or scanf and saying I'm trying to access the keyboard ports. Well, that means that compiler doesn't work on the platform. I mean, if that compiler is trying to do this type of stuff, includes libraries with it that are doing this, then obviously that's not compatible with the platform. Other people will say, interrupts occurred. Well, now you're blaming the operating system. I've already said that what did you do wrong in your program? So it's something that you specifically did wrong. And obviously, if you look at your code, you're not going to find this instruction. Right, so there are three basic answers for this instruction, for this question here. Three basic answers. And One of them is not an ANSI answer, but I'll throw it in here. So in order to know that you executed this, and even if, so one of the things people would ask, is it the address in my program? And we'll say your program is from 4,000 to 5,000, right? And we'll say, yes, it is in between that address range. So it's actually in your program. So one thing you should realize is that you probably should not have executed that program. The compiler is not going to compile it in your program. It's not going to be there. It shouldn't be there. So the only thing is, you went off into the weeds somewhere and somehow executed an instruction you should not have executed. That's really the explanation there. So there's three typical answers. Now the first answer is stack corruption, right? So whenever you make a function call, the return address is put on the stack, and some architectures may be put in a register before it's put on the stack, but put on the stack. Now, if you've overwritten that address with, let's just say a simple example would be that, let's say you were supposed to return to 40201, right? And you corrupted this last byte to say 40202. Well, if the instruction you're returning to is more than 1 byte opcode, you're now returning into the middle of the opcode. It was an instruction that was not intended to be executed to begin with. And so now you're executing an unknown instruction, which may be this instruction. See, the reason why this instruction is picked is because you shouldn't be executing at all in user mode. I mean, you could have executed a whole bunch of benign instructions until you hit an instruction that actually does cause a fault. But I can't say for this problem, give you some random instruction like, you did a memory access violation. Well, that could be a lot of things. But specifically executing an instruction that can't exist, it's really hard to get to that point without jumping to a location where you shouldn't have executed to begin with. So you change 1 byte. I mean, you could have changed this whole thing. It doesn't really matter. But somehow you changed it so you executed a path that was not intended to be executed. So one is stack overflow, right? Or buffer overflow. You've overflowed the buffer. You've overwritten part of the return address. The second one is very simple, is function pointers. Obviously, you could have corrupted a function pointer. There could be function pointers in memory tables. They're jump tables that get overwritten. So that's the second one is, you didn't initialize your variable, or you got overwritten, or you wrote it with the wrong value. So that's the second one, function pointers. The third one. Now the third one, again, like I said before, is a non-ANSI answer. And this is mismatch of calling conventions. So calling convention is where the caller and callee of a function, function A calls function B, they both agree how they should pass the parameters. It should be on the stack, should be in registers. They also agree who cleans up the stack. Does the callee clean up the stack? Does the caller clean up the stack? And so if they mismatch, they don't agree. So for example, one uses a calling convention, we'll call it C calling convention. The other one uses Pascal calling convention or standard calling convention. So they mismatch and they either both clean up the stack or neither of them clean up the stack. You're eventually going to get to a place where you return, the stack is misaligned and you return to a wrong location. So the third one is incorrect calling conventions. So those are the three main ways that you can execute, that you could cause a problem in your program that could have gotten to execute an invalid instruction. Now, I could have changed this instruction to been something else. Like I said, you could have been even move CR 0,1. I mean, you can't do that in user mode either. So the whole thing here is to recognize that you've gone down a wrong code path. Somehow you've got there, and the only way to get there is by transferring to a flow in your program that's not valid. And how do you do that? The most simplest answer is you've returned or you've called a variable that held a location, which the variable, I mean, it could be the stack location, or it could be a variable like a function pointer that contained an address that you jumped to that was not intended. And stack overflow, uninitialized function pointers, mismatched calling conventions are the three main answers for this. So that is the answer to this debug question.